Welcome to this presentation on best sightseeing pair problem. In this session, we will walk through the problem, discuss the approach, and see the code implementation. Let's dive in. Our objective is to find the maximum score for sightseeing pairs from an array called values. The score for a pair ij is defined as the sum of values at indices I and j plus the difference in their indices. Score ij equals to values I plus values j plus I minus j. We are given constraints where the length of the array can be large, so as an efficient solution is necessary. Looking at the formula, we can make an important observation. The score can be broken down into two parts. Score ij equals to values I plus I plus values j minus j. This insight helps us maximize values I plus I for all indices I less than j and then add values j minus j for each index j. By tracking the maximum of values I plus I, we can optimize our solution. The approach involves two main steps. First, we initialize max I to values 0 to track the maximum of values I plus I. Next, we iterate through the array. For each index j, we compute the score for the pair ij and update max score as we go. After each step, we also update max I with the maximum of the current value of max I and values j plus j. This allows us to efficiently compute the maximum. Here's a quick overview of the algorithm. The time complexity is big O of n because we only need to traverse the array once. The space complexity is big O of 1 as we only use a few variables to keep track of max I and max score. This makes the solution both time and space efficient. Now let's take a look at the code implementation. The solution is straightforward. We initialize max I with value 0 and iterate over the array starting from index 1. For each index j, we calculate the score and update max score. We also update max I with the maximum of the current value of max I and values j plus j. The final value of max score is our result. Let's walk through an example to understand how the solution works. Given the input array values equals to 8, 1, 5, 2, 6, we initialize max I equals to 8 and max score equals to 0. At each step, we update the score and max I as follows. For j equals to 1, max score equals to 8. For j equals to 2, max score equals to 11. And for j equals to 3, max score is also 11. For j equals to 4, max score still remains 11. The final output is 11. In conclusion, the solution is efficient and works well even for large arrays due to its time complexity of big O of n and space complexity of big O of 1. We used a mathematical transformation of the problem to simplify the score calculation, making it possible to solve it optimally with a single pass through the array. Thank you for your attention.